Have you ever asked yourself if our universe, our reality, is all it seems, or could we be living in a hologram? Welcome to the fascinating realm of the holographic universe theory. This idea, which might seem straight out of a science fiction novel, has serious origins in the field of theoretical physics. In the 1990s, two brilliant minds, Gerard T. Hooft and Leonard Susskind, laid the groundwork for this theory. The basic premise? Our perceived three-dimensional universe might just be a projection of information encoded on a two-dimensional surface. Imagine it like a hologram on a credit card. The image appears three-dimensional, but the information is stored in just two dimensions. This concept suggests that everything we see, feel, and experience, from the vastness of galaxies to the smallest particles, could all be an illusion, a holographic projection of a two-dimensional reality. So, are we living in a two-dimensional reality that's merely projecting a three-dimensional illusion? Let's dive deeper. At the heart of the holographic universe theory is the holographic principle. The holographic principle is a tenet of string theories and a supposed property of quantum gravity that states that the description of a volume of space can be thought of as encoded on a lower dimensional boundary to the region, preferably a light-like boundary like a gravitational horizon. Think of a hologram. When you look at a holographic image, every part of the hologram contains all the information possessed by the whole. The whole here is our three-dimensional reality. The parts are a two-dimensional surface that contains all the data needed to describe it. Now let's delve into the fascinating world of black hole physics. Black holes, as per Einstein's theory of relativity, are regions of space where gravity is so strong that nothing, not even light, can escape their pull. But in the late 20th century, physicist Stephen Hawking proposed that black holes are not completely black, but can emit small amounts of thermal radiation. This is now known as Hawking radiation. This concept revolutionized our understanding of black holes and gave birth to the idea that perhaps information about what falls into a black hole is not lost but rather stored at the event horizon, the boundary around a black hole from which there is no return. And this idea forms a key connection between the holographic principle and black hole physics. Now let's go a step further. What if all the information in our universe is encoded in a similar manner? What if our three-dimensional world is actually a projection of information stored on a two-dimensional surface, much like a hologram? This is the crux of the holographic universe theory. Everything we perceive to be three-dimensional may actually be painted on a two-dimensional surface, like a grand and complex painting on the canvas of the cosmos. In this model, everything you see, feel, and experience is a projection from a flat two-dimensional surface. The holographic universe theory isn't just a wild idea. There's some evidence to back it up. Let's delve into the scientific observations and experiments that give credence to this fascinating theory. Quantum physics, for instance, has long grappled with the concept of quantum entanglement, particles mysteriously linked regardless of distance. This curious phenomenon aligns with the holographic principle, suggesting the universe operates in dimensions beyond our everyday perception. Turning to astrophysics, researchers have discovered peculiarities in the cosmic microwave background radiation, the afterglow of the Big Bang, that hint at a holographic universe. They found unexpected levels of noise or random fluctuations in the data. This noise is thought to originate from the very fringes of the universe, potentially indicating a boundary where information about the universe is encoded on a two-dimensional surface. These findings suggest that our universe might indeed be a hologram. The evidence is compelling, but the exploration is far from over. The quest to decipher the true nature of our universe continues. Gravity, the force that binds the universe, also plays a crucial role in the holographic model. Now let's unravel how gravity fits into this fascinating framework. Gravity, as we perceive it, is a result of curved space-time. But in the holographic model, gravity isn't a fundamental force. Rather, it's a byproduct of quantum entanglement, arising from the complex interplay of information on a two-dimensional surface. But how about gravitational waves? Those ripples in space-time, detected for the first time a few years ago? Well, they fit snugly into this model too. As these waves pass through the universe, they slightly alter the information encoded on the boundary, creating what we perceive as oscillations in the fabric of space-time. These waves, then, provide a direct link between the macrocosm of gravity and the microcosm of quantum mechanics, offering a tantalizing hint that the holographic model might just be onto something. Gravity, then, could be the key to unlocking the true nature of our universe. Quantum entanglement, a strange phenomenon of quantum physics, might also support the holographic universe theory. This fascinating principle describes how two particles can become inextricably linked, no matter their distance apart. They could be on opposite ends of the universe, yet a change to one instantaneously affects the other. It's as if they're two sides of the same coin, or perhaps two faces of the same hologram. In the context of the holographic principle, quantum entanglement could be seen as a network of connections that link all particles across space-time. This vast web of entanglements has been compared to a holographic projection, similar to how a two-dimensional image can give rise to a three-dimensional hologram. Imagine the universe as a giant hologram, with every particle entwined in a cosmic dance of entanglement. This dance could be the underlying structure of our universe, the fabric of reality itself. This entanglement could be another piece of the holographic puzzle. Cosmic microwave background radiation, the afterglow of the Big Bang, also plays into the holographic universe theory. This radiation is a snapshot of the universe at a very early age, roughly 380,000 years after the Big Bang. It's like the universe's baby picture, and just like how we analyze a child's growth from their earliest photos, scientists study this radiation to understand the universe's infancy. Now, how does this relate to our holographic universe? Well, some patterns in the cosmic microwave background radiation seem to suggest a holographic explanation. One such pattern is the large-scale smoothness of the universe. Despite being billions of light-years apart, regions of the universe have the same temperature. This too-smooth-to-be-true phenomenon is a potential hint at a holographic origin. Anomalies, too, in the cosmic microwave background radiation are intriguing. They could be mere statistical flukes, or perhaps they are whispers of a holographic universe. The secrets of the universe might be hidden in this ancient light. Like any scientific theory, the holographic universe theory faces its share of criticism. Critics often point to the lack of direct observational evidence as a major roadblock. They argue that while the theory is mathematically elegant, it still doesn't provide a comprehensive explanation for all physical phenomena. For instance, it struggles to incorporate dark matter and dark energy, two key elements of our current understanding of the cosmos. Other researchers propose alternative theories. Some favor the traditional view of a three-dimensional universe with time as a separate dimension. Others propose more exotic models like string theory or the multiverse hypothesis. These theories, while equally unproven, offer different ways to interpret the same physical evidence. Moreover, even supporters of the holographic principle acknowledge its speculative nature. They agree that we need more research and more data to fully flesh out and test the theory. While the theory is intriguing, it's important to consider all perspectives. If the holographic universe theory is correct, it could fundamentally reshape our understanding of reality. Let's dive into what this means. Think of the universe as a hologram, where every tiny piece holds a complete image of the whole. If we accept this model, our understanding of space and time is turned upside down. Space and time, instead of being fundamental realities, become emergent properties, arising from deeper, more fundamental realities. This radical shift brings with it philosophical implications. Are we living in a projected reality? Is consciousness then a part of this holographic projection? These questions challenge our traditional understanding of existence and identity. Moreover, the holographic model could lead to a paradigm shift in physics. By unifying quantum mechanics and general relativity, it paves the way for a new understanding of the universe's fundamental laws. The implications are profound and mind-bending. Embrace the possibility of a reality far different and far more fascinating than we ever imagined. The holographic universe theory isn't just theoretical, it could have practical applications as well. For instance, this theory could revolutionize the field of quantum computing. By understanding the universe as a hologram, we might be able to develop quantum computers that can process vast amounts of data simultaneously, leading to unprecedented computational power. Moreover, the holographic principle could also impact the field of cosmology. It could provide new insights into the nature of black holes and the origins of the universe, helping to solve some of the most profound mysteries of our cosmos. As for future research, scientists are keen to test the holographic universe hypothesis more rigorously. This involves developing more sophisticated mathematical models and conducting experiments that can provide direct evidence of the holographic nature of the universe. In essence, the holographic universe theory opens up a whole new frontier of scientific exploration, The future of our understanding of the universe is exciting and full of possibilities. The holographic universe theory is a radical and fascinating idea that challenges our perception of reality. We've delved into its theoretical foundation, rooted in the holographic principle and black hole physics. We've examined how information could possibly be encoded on a lower dimensional surface, thus creating the universe we perceive. We've explored compelling evidence from quantum physics and astrophysics, discussed intriguing patterns in the cosmic microwave background radiation, and pondered the role of gravity and quantum entanglement in this holographic model. We've also addressed the criticisms and debates surrounding this theory, along with the alternative theories and viewpoints that exist. The implications of accepting the universe as a hologram are profound, potentially reshaping our understanding of space, time, and reality. And the possibilities for practical applications and future research are as vast as the universe itself. So let's keep exploring, questioning, and discussing. As we continue to explore the mysteries of the universe, who knows what other startling discoveries await us.